Solve 1 over x equals 1/9 minus 5 over 9x. This is a rational equation, which is basically an equation that has rational expressions in it. And just like other equations that had fractions in them, if we want to solve these, we're going to get rid of the fractions by multiplying both sides by the LCD. But there's a slight difference here, because with rational equations, there are possibilities to have variables inside the denominator. Let's take a look at this one. Here we have 1 over x, so there's an x in the denominator. And here we have 5 over 9x, so we have a 9x in the denominator. Now, we know that when we're dealing with fractions, the denominator cannot be 0. This is a rule. We are not allowed to divide by 0. And in this case, there are two denominators that have x's in them. There's x and 9x. So we know that x is not allowed to be 0. And also 9x can't be 0. And so this first inequality, I say inequality because it's not an equation, it's not equal to. This first inequality tells us that x is not allowed to be 0. The second one actually gives us the same thing. If we divide both sides by 9, we get x cannot be 0. And we call this a restriction. Now, there is a chance, and we'll see later in some of the other examples, that we multiply by the LCD and we solve the equation and we do all of the steps that we're supposed to do. And in the end, we get a solution like x equals 0 that's not allowed because it would give us a 0 in the denominator. This is going to give us one additional step in these problems. At the very end, we need to check and make sure that our answer isn't one of the restricted numbers. Otherwise, it's not a real solution and we have to throw it away. Let's go through this problem and try and solve it and see whether or not the solution fits the restrictions that we have. I'm going to rewrite the equation over here. 1 over x equals 1/9 minus 5 over 9x. Just like any equation that has fractions in it that we're trying to solve, we want to start by multiplying both sides by the LCD. In this case, the denominators have x's in them, so the LCD has to have an x in it. Also, there are 9's that are factors in the denominators, so the LCD will also have to include 9. And so in this problem, the LCD is just 9x. So we need to multiply both sides of this equation by 9x to get rid of the fractions. Let's look at the left-hand side first. If we take 9x times 1 over x, we're going to have the x's cancel because one is in the denominator and one is out front. So we just need to multiply 9 times 1, and that gives us 9. On the right-hand side, we're going to have to distribute the 9x to both of the terms. When we distribute the 9x in the first term, we notice that the 9's will cancel because there's one in the bottom and one out front. So in the end, we just have x times 1, which is x. Then we have minus. In the second term, we've got a 9x in the bottom and a 9x out front, so the 9x's will cancel. That just leaves us with the 5. So in this case, we have 9 equals x minus 5. To get x alone, we just need to add 5 to both sides. And since 9 plus 5 is 14, we end up with x equals 14. Now at the very end, we need to look at the restrictions. Remember that we said x was not allowed to be 0. In this case, we got x equals 14, so that's not a problem. This works as a solution, and so I'm going to box that in and have that be our solution. In the event we had done all of this, and in the end we got x equals 0, we would have to throw that away. It's not allowed to be a solution because that would give us a 0 in denominators, which is undefined. So we've got to keep out for that. We call those extraneous solutions, and we will see them in some of the later problems. So definitely keep an eye out.